Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of game theory. In today's lecture, we are going to see a problem based on two-person zero-sum game with saddle point. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let us move on to the problem. Problem says that in a certain game, player A has three possible choices L, M and N, while player B has two possible choices P and Q. Payments are to be made according to the choices made. So here in this table it has been shown that if A plays strategy L and B plays strategy P, then A pays B rupees 3. Similarly, if A plays strategy L and B plays strategy Q, B pays A rupees 3 and so on. And on the basis of these, we need to find out what are the best strategies for player A and B in this game. What is the value of game for A and B? What is the game fair? Is the game strictly determinable? So first of all, we need to make a payoff matrix for either of player A or B. So let us first make the payoff matrix for player A. For player A. Now, as we know that player A has three strategies L, M and N, and player B has two strategies. So let this be player A and it has strategies L, M and N, and here is player B which has two strategies P and Q. And from this table we need to find out the value of payoff matrix. So for L and P, that is if A plays strategy L and B plays strategy P, then A pays B rupees 3. That means if A plays strategy L, B plays strategy P, then the value here is A pays B rupees 3. That means A is losing rupees 3. So this will be minus 3. Because A is losing money and this is payoff matrix for A. So anything that A gains will be positive and anything that A loses will be negative. Similarly, if A plays L and B plays Q, if A plays L and B plays strategy Q, then P pays A rupees 3. That means A is gaining rupees 3. So if A plays L, B plays Q, B pays A rupees 3. That means A will gain rupees 3. Similarly, for M, P, that means A plays strategy M and player B plays strategy P, then A pays B rupees 2. So A pays B, that means A loses B. So if A plays M, B plays P, then A pays B rupees 2, or we can say that A loses rupees 2. Similarly, M, Q, B pays A rupees 4. For M, Q, that means A plays strategy M and B plays strategy Q, then B pays A rupees 4. So A will gain rupees 4. Similarly, N, P, B pays A rupees 2. So if A plays N, B plays P, then B pays A rupees 2. So A will gain rupees 2. Similarly, N, Q, B pays A rupees 3. That means if A plays N, B plays Q, then B pays A rupees 3. So A will gain rupees 3. So we have prepared our payoff matrix now. Now we need to calculate the saddle point, or we need to find out the saddle point. Remember that in each game theory problem, our first step will be to find out the saddle point, and if the saddle point exists, we got our solution, and if our saddle point does not exist, then we will go for further calculation. So let us start here. In order to calculate the saddle point, first we will calculate the row minimum. So we will calculate row min. Now in this we will take the minimum values in the row. So for first row, minimum value is -3, so this will be -3, this will be -2, and this will be +2. Now among these values we need to see which is the maximum value here. So we can see that here the maximum value is +2. So this +2 we select, and this is called maxi-min value. Maxi-min value. So this is maximum of minimum. So this is our maximum value. Similarly, we will calculate another value which is column max. Column max. In this we will select the maximum value in each column. So here we can see that here the maximum value is +2, and in the second column maximum value is +4. Now among these two we will select the minimum value. So among these two the minimum value is +2. So this value we call it a mini max value. Mini max value. So we have calculated maximum value and minimax value, and if maximum value is equal to minimax value, then we know that our saddle point exists. That means in this problem we can see that maximum is +2, minimax is +2. So maximum is equal to minimax. So for this we know that there is a saddle point in this game which says that the intersection element of this row and column is the saddle point, which indicates that player A will continuously play strategy N and player B will continuously play strategy P 100% of time, and player A will not play strategy LM and player B will not play strategy Q. So we can say that in this problem saddle point exists. So the strategy for player A and B can be, so strategy for player A, and we know that player A has 3 strategies. So we can see that this can be written as 0, 0 and 1. This shows that player A will play strategy L 0% of time, strategy M 0% of time, and strategy N 100% of time. Similarly, strategy for player B, as we know that player B has 2 strategies P and Q, so it can be written as 1, 0, because player B will play strategy P 100% of time and player B will play strategy Q 0% of time. So these are the optimal strategies for the player A and B. Now let us come on to the second part. What is the value of game? So whenever we are having a saddle point in a problem, then the element of that saddle point, or we can say that the value of maximin is equal to value of minimax is equal to the value of game. So we can see here that the value of game for A and B both will be equal to the maximin and minimax value, which is equal to +2 in this game. Now let us move on to the third part. Is the game fair? So we have done this and we have seen the conditions for a game to be fair in our previous lecture also. So based on that, we know that for a game to be fair, the maximum value has to be equal to minimax value, which has to be equal to 0. So if this condition satisfied, then we can say that our game is fair. Now for this particular problem, we can see that the maximum value is equal to minimax value, both the values are +2, but they are not equal to 0. That means this game is not fair. So we can write here that the game is not fair. Now moving on to the last part, is the game strictly determinable? So in the previous lecture we have also seen the condition for which a game can be strictly determinable. So for that, the value of maximum has to be equal to value of minimax, which is not equal to 0. Remember that for strictly determinable game, maximum is equal to minimax and they are not equal to 0. So for this particular problem, we can see that maximum value is equal to minimax value, but they are not equal to 0. So we can say that this game is strictly determinable. So I am writing it here. This game is strictly determinable. So we have solved this problem, but we need to understand the main concept of saddle point, that is the calculation of maximum and the minimax value. So let us understand this again. So player A has 3 strategies L, M and N, and player B has 2 strategies P and Q. Now player A, knowing that player B is equally intelligent player, which will allow only minimum advantage. So among each strategies, player A knows that for each strategy player B will allow him minimum advantage to take. So among each strategy, player A will take the minimum value from each strategy, or we can say each row. So that's why we have calculated this row min. Now in order to maximize that minimum possible gain which B allows A to take, so in order to maximize this, we will select the maximum value among this. Similarly, when we see player B knows that player A is an equally intelligent player and will try to maximize the loss for B. So for each strategy that B plays, B will select the maximum loss that A can cause. So for strategy P, the maximum loss is +2. For strategy Q, the maximum loss is +4. So these are the maximum loss that A can cause to B. Now B will try to minimize this maximum loss. So among these two values, we will select the minimum value, which we call the minimax value. And when these two values are equal, we get a saddle point which says that the best strategy for player A is strategy N, and here player A did not need to play any other strategy than strategy N. Similarly, player B has the best strategy as strategy P, and player B did not need to play any other strategy than strategy P. So I hope you understand the concept behind this, and in the previous lecture we have seen the basic introduction of the game theory and the important terminologies in game theory. So if you have not watched the previous video, I request you to please go and watch the previous video, and if you like this lecture, please share the lecture. Have a nice day. Thank you.